Welcome back, guys, and what we're going to be looking at in this tutorial today is our next section on coordinate geometry, which is going to be coordinate geometry of the circle. Now, it's very important that before we start off today that we open our log tables to page 18 and 19, because as we go through coordinate geometry of the circle, we'll still be using formula from coordinate geometry of the line and expanding into new formula. Now, the first one we're going to look at today is a circle with the center 0, 0. Now, when we look at the circle with the center 0, 0, okay, it's very important that we know this formula. X squared plus y squared is equal to r squared, where r is going to be our radius. Now, a reminder that the radius of a circle is a point from the distance from the center to the edge of the circle, okay, as you can see here from the point r, from the line r. So the formula x squared plus y squared equals r squared is not in our log tables, but you may want to add it in on page 19 so that you have it for future reference. Now, what we're going to be looking at today here is example 1. And I always find it very useful when looking at coordinate geometry of the circle to give ourselves a little diagram to help us. So the first one here says, a circle has its center 0, 0 and passes through the point 3, minus 1. So if I had to draw a sketch of this circle, okay, I can see that the center in here is going to be 0, 0 and that it's telling me a point 3, minus 1, which I'm going to say is over here, is on the circle, which means that my radius is going to be the distance between those 2 points, which I'm going to label r. So part 1 here says to find the length of the radius of the circle. Well, I know if I want to find the length of a line or the distance between 2 points, the formula that I actually need to use here is the distance formula on page 18, which means that I'm going to use that r is actually equal to the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared, where I'm going to have my two coordinates labeled x1, y1, x2, y2. And now I'm going to plug them into the formula to find the length of that line, to find the length of my radius. So let's sub these in here. So instead of x2, I'm going to have 3 take away 0 to be squared, plus minus 1 take away 0 to be squared, which means I get the square root of 3 to be squared plus minus 1 to be squared. 3 squared is 9, plus minus 1 squared is 1, so I actually get the square root of 10, which if we put into our calculators, guys, just leaves us with the square root of 10 units. So therefore, the radius of our circle is the square root of 10. So now when we look at part 2 here, part 2 here says find the equation of the circle. Now, because I know the center is 0, 0, I know I'm going to use the formula x squared plus y squared is equal to r squared. X and y stay the same because it's the equation of a circle, so I leave it as x squared plus y squared. But instead of r squared, I'm going to sub in my radius. So in the last question, I found that my radius was the square root of 10. So I'm going to put in the square root of 10 to be squared. Now I know that the square root and squared are opposite to each other, so they cancel, which leaves me with x squared plus y squared is equal to 10, and this is my equation of the circle, guys. So if I wanted to prove that a point was on the circle, I could just sub it into this guy to be able to prove that. Okay, so take a minute here, pause the video, add this example into our notes booklet that you can find in the Files tab on Teams, and then we're going to move on to the next example here. So in example 2, we need to understand the word tangent. So a tangent may be a new word to you, but a tangent is just a fancy word for a line. Specifically, it is a line that touches a circle at only one point and is perpendicular to the radius. Now that's very important here. So you can see that the radius of our circle in this diagram would be the line from O to P. And we know that the tangent is perpendicular to that line here, okay? And that's a key property we need to remember as we move forward with our problems. So example 2 says the line 2x plus 3y minus 13 equals 0 is a tangent to the circle with centre 0, 0. So as soon as I see that the centre of the circle is 0, 0, I know I'm using the formula x squared plus y squared is equal to r squared. Okay? Then it tells me find the equation of this circle. So I know my formula. I have my x squared plus y squared is equal to r squared. What I'm missing here is the point P that I'm going to need to find the distance. Okay? Or we can use another formula that we looked at in coordinate geometry, which is to find this distance r. And to find this distance r, the key thing is it's perpendicular. So on the top of page 19, this time to find my perpendicular distance r, I'm going to use my perpendicular distance between a point and a line formula. So r is going to be equal to ax1 plus by1 plus c all over the square root of a squared plus b squared. Now it's key to remember, guys, we can only use this formula because we know it's a tangent and we know a tangent is perpendicular. Okay? Now, if we look at our equation here so we can see what we need to sub in, I can see that a is going to be 2, b is going to be 3, and c is going to be minus 13. My x1, y1 is going to be my point 0, 0. So now let's sub this in to see what we get. So I get 2 by 0 plus 3 by 0 minus 13 all over the square root of 2 squared plus 3 squared. Which means on top I'm left with the modulus of minus 13, which we know is going to turn into a plus, over the square root of 4 plus 9, which means I get 13 over the square root of 13, which, guys, if you put into your calculator 13 over the square root of 13, it just gives me the square root of 13. Now, sorry guys, I don't know why that zoomed in like that. Apologies. And it's not going to let me zoom out. There we go. Okay. So that should give me the square root of 13 units. So I now know that my radius is the square root of 13 units. So I'm going to use my formula again. X squared plus y squared is equal to r squared to find my equation of a circle. Instead of r squared, I'm going to put in the square root of 13. So I get x squared plus y squared is equal to the square root of 13 to be squared. Again, the square root of 13 and the squared are going to cancel, which means I'm left with x squared plus y squared is equal to 13. And this is my final answer. So take a minute, guys, add this example 2 into our notes booklet as well, and then we're going to finish up and try a few questions. Thanks very much, guys, and well done for your hard work. Bye now.